Hi everyone, my name is Shankar and in this video I'll talk about matrix chain multiplication. It's not just well known for interviews but also a new type in dynamic programming. So let's get started. We are given an integer array which shows dimensions of n minus 1 matrices where n is the size of this array. So these two values are showing dimensions of matrix 1. These two are showing dimensions of matrix 2 and so on. Now, because these values are dimensions of matrix, so they can't be negative for obvious reasons. And I will also tell you two more cases and will tell you what should be the expected answer. So we are given the integer array and we have to find minimum number of operations by which we can get all of them multiplied. So every matrix to be multiplied and we have to return the minimum number of operations. So minimum number of operations we have to return. Now, before telling you the solution, let's understand what would be our answer in this case and in this case. So in this case, we understand that this array is showing just one matrix. So for this, the number of operations is 0. There is nothing minimum, nothing maximum. There is single matrix, so we cannot multiply it, and so our answer is 0. And in this case, it's not even showing any matrix. So for this case also, I'll consider my answer to be 0. Now after understanding all these cases and getting what we have to return, minimum number of operations to get all of them multiplied, I'll first tell you the brute force solution. And for that, I got this algorithm right over there. But before telling you the algorithm, let me make you understand how it works. So now we understand for a given matrix with size n, if n is less than equal to 2, then return 0. I just show you the case. For example, I can say, what is my idea with brute force? For every element, what I will do is, suppose for this element, what I will do, I'll get all numbers to left of it as a subproblem 1, all elements along with this in right as subproblem 2, and I'll first get the minimum cost to solve this subproblem, cost 1, then minimum cost to solve this subproblem, cost 2, and after solving the matrix in left part, I'll get matrix 1. After solving all this, after solving this, I'll get matrix 2, and this will have dimensions R1 C1, this will have dimensions R2 C2, where basically these two are equal, the obvious condition for multiplication. Now after calculating this cost and this cost, for this partition my answer will be C1 plus C2 plus R1 into C1 into C2. This is my answer when I'll have partition at this place. Now, can I have partition over here? No, we can't. Why? Because there is no matrix in left part of it. It's just a single integer and we can't do that. So, I can't have partition at this place. And if I talk about this place, no, I can't have partition over there as well because this is not any matrix. So, for this problem, my possible places for having partition are this to this. So for a given question, I will write this problem as this array, I as starting index, j as ending index, and my partition will go from I plus 1 to j minus 1 partitions. And for every partition, I'll calculate left subproblem, right subproblem, and cost for multiplying these two submatrices or subproblems, and that will be the cost for current partition, coast for current partition 1, this will give me coast for current partition 2, and for this whole problem the answer will be minimum of all of them. Simple. Now if this makes sense then we are good to go. If it doesn't, you should repeat this video. Okay, let's come to the algorithm part now. So here is algorithm part. First thing is, we are given a problem with the name of array, starting index, ending index, and if I plus 1 is greater than equal to j, this means the size of matrix or array is less than equal to 2. In that case, return 0. After this, what I will do, for every partition, this means from I plus 1 to j minus 1, I'll get minimum number of operations, and I told you the formula for this. It is subproblem 1 plus subproblem 2 plus, for this, a I multiplied to p multiplied to a j. So I'll calculate this for every partition and will store answer and this minimum into my answer, which is actually nothing but minimum ops. So minimum operations, I'm writing again over here. So for every partition I'll do this and then return minimum number of operations, which is our answer. Okay, so I hope this brute force makes sense to you now. Let's understand what will be the optimized way, because we are having some problems over here, and for a given matrix, for this partition we will have this subproblem, and if I had more element, then for this partition I had this subproblem, and then again I would have this subproblem. There will be overlapping subproblems, for which I will use DP and nothing but just simple memoization. So what changes I will make in this algorithm? If this is the case, then return 0. There will be an addition if min ops for I j is not equal to -1, this is change 1, and another change will be here, return min ops I j equal to this. Only these two changes will make it memoized. But what is this? So it is nothing but just a simple matrix with number of rows is possible values of I, which is 0, 2, n minus 1, and is the size of original array, and j will be column, so it will again from 0 to n minus 1. This was the function given to me. This is the matrix I created for this class, and this is the function I used as utility I created myself. So first I created this matrix with size 500 cross 500. Then in this function I initialized every position with -1. Then I will solve this whole thing and return whatever I get as the answer for 0 and -1. So in this function, the pointer to array I and j are given as parameters. If I plus 1 is greater than equal to j, then return 0. If minimum operations for I and j are not minus 1 in this matrix, then I have already calculated it. So return minops ij. Otherwise, I am to calculate for every partition for this given problem. So initially my best answer is int max because it will be minimum at the end. So I'm initializing it with int max. Now for partition from I plus 1 to j minus 1, partition increasing, best answer is minimum of previous best answer and minimum operations on left side from I to partition, then minimum operations from partition to j, that's on the right side, then ARRI, partition and j, and getting sum for all of this. Now my best answer will have minimum value, and after this loop I'll return best answer after storing it in this matrix at ij index. So this worked. So before you leave this video, let me tell you why I didn't use tabulation and why I used memoization. So you will see that first this, then this, then this, then this. These cells will be filled first, and this will be our answer in this special type of problem in DP. So writing tabulation with I going in this way, then in this way, then in this way was little complex. I hope after watching this video you understand what is matrix chain multiplication. If you understand all this, make sure to like the video and subscribe to this channel.